All righty, blue math up here. Yellow math, thank you so much for your silent work while we're doing this. So I want to make sure that we understand and know the four concepts that you have to be able to do in order to add and subtract fractions with unlike denominators. So we're going to go through those four skills as a review right now. And I'm going to tell you right now, today is Thursday. So far, I have not taught you a single fifth grade standard. All these standards that we've learned, finding equivalent fractions and simplifying, are fourth grade standards. So we need to make sure I'm letting us review it because it is so important that you know how to do those things in order to be successful in adding and subtracting fractions with unlike denominators. So it's very important that you're taking these notes and really staying focused to do that review. Okay? So the first skill that we talked about was finding equivalent fractions. Yes, please. So if I have the fraction 3/4, I want you to find equivalent fractions, one of them which has a denominator of 12, and the other one which has a numerator of 6. Right now on your paper, find the common or the equivalent fraction.
What does the comma mean?
Two different fractions. So I want one equivalent fraction with a denominator of 12 and another equivalent fraction with a numerator of 6. What are those fractions that are going to be equivalent to 3/4? Some people are solving them and some people are looking at the board thinking about what to do. So let's review what we need to do to find equivalent fractions. Equivalent fractions can only be done using multiplication or division. You can never do adding or subtracting to find equivalent fractions. So I need to look at this. I need to look at my denominator first. What did you do to make an equivalent fraction with a denominator that used to be 4 and now it's 12? How did you go from 4 to 12? I multiplied by 3. So what do I need to do to my numerator to find my numerator of my equivalent fraction? I have to also multiply it by that same number. 3 times 3 is? 9. Same steps if you are given a different numerator. What do I do to get from my original numerator of 3 to my equivalent fraction numerator of 6?
You have to multiply by 2.
Not times 3, because 3 times 3 is 9.
2.
Times 2. So what am I going to do to my denominator to find an equivalent fraction?
By 2.
Multiply it by 2. What's 4 times 2?
8.
8. Awesome job.
So
That is skill number 1. Yes.
So I thought, so with our fractions 3/4, two equivalent fractions are 9/12 and 6/8. 6/8.
Correct.
But 9/12 isn't equivalent to 6/8.
Okay. It actually is equivalent to 6/8,
Yeah.
but you can't go using whole numbers from 12 to 8. You could technically do that by using a decimal. So I completely see where you're coming from. It looks like 9/12 and 6/8 aren't equivalent, but don't they both simplify to 3/4?
Yeah.
So they are equivalent. They're just not compatible when it comes to using whole numbers to find them. If we were to use butterfly method to see if they were equivalent, 12 times 6 is
72.
72, and 8 times 9 is?
72.
So knowing what I know about how to tell if something's equivalent, they are. And I'm going to leave it at that. Because the way to go from 12 to 8 is to multiply 12 times a decimal.
So then will that, like knowing how to do
You will never have a problem where you'll have to multiply
I was
by
just
a
wanting to
decimal
know
or
because
fraction.
If we ever had a test or quiz on it, and like I put down those fractions, I'd be like, wait, the 9/12 isn't equivalent to 6/8, so that must not be the answer.
But then we've proved that they were, in fact, equivalent.
So butterfly
You just
method.
couldn't, it wouldn't be easy to go from 9/12. Actually, Yeah, it wouldn't be easy to go from 9/12 to 6/8. But you could go from 9/12 to 3/4 and then from 3/4 to 6/8. Okay, Yusuf?
Wait, why'd you multiply it by 3 first and then by 2? Because whatever you did at the top.
Because, yeah, so in the first equivalent fraction, to make a common denominator or a common equivalent fraction with a denominator of 12, you have to multiply your denominator by 3. So you do the same thing to your numerator. This times 2 was for my second fraction. Christina?
Last year when we were learning how to make a equivalent fraction, if the denominator of that couldn't we divide 12 by something and then divide 9 by something?
That would be simplifying, which is our next topic. Our next topic is simplifying. When it comes to simplifying fractions, that's what you're talking about, Christina, with finding equivalent or common factors to make it smaller. So for example, if I told you you get 15/20ths of the pizza. Can you picture 15/20ths in your head?
No.
Not really that easy because this is not simplified. So remember, we have 6 questions that we can ask ourselves to see if something is simplified or help us to find how to simplify it. Question number 1, is my numerator 1?
No.
No, so I could possibly simplify it. Question number 2, is my numerator 1 less than my denominator?
No.
No, so I could maybe simplify it. Question number 3, is this a number over its double?
No.
No, that would have to be 30 as the denominator for it to be over its double. Okay, question number 4 is, can the denominator be divided by the numerator?
No.
Nope. Question number 5 is, are they both even?
No.
Nope. So question number 6 is, do they share any common factors? Let's find out. What are my factors for 15? 5 and 1 does not count because anytime you multiply or divide by 1, your value doesn't change. What are my factors of 20?
5.
Wait, 5 times what?
4.
4, okay.
10.
10 and 2 and 20 and 1. Do they share any common factors? 5. So that means I can take 15 and divide it by 5 and 20 and divide it by 5 to simplify into an equivalent fraction of 3/4. Now, is simplifying one time always going to lead you to the simplest answer? No. So now we want to go back through those 6 questions to make sure we're as simple as we go. Is the numerator 1?
No.
Is the numerator 1 less than my denominator? So is it simplified?
Yes.
Awesome job. Okay? You have to make sure that you can simplify every single answer. That's your goal, is to be able to simplify them. Okay? All right, now we're going to talk about 2 skills, that one of which you probably have already learned about. The other one, maybe not. Let's start with changing improper fractions into mixed numbers. So let's say I had right here, I've got 10/8. Looks good right now, right? 10/8. Using a fraction bar, I know I'm in 8 pieces. I know I have 10 of those 8 pieces. What does that mean if I have a numerator that's bigger than my denominator? What does it mean? It means I have an improper fraction, which in other words means I have at least 1 whole. So here's a fraction bar that represents 1 whole. You can see that because my denominator is 8, 8 pieces are equivalent to 1 whole. So I can break my fraction apart and regroup the 8/8 that really represent one whole. And how many eighths do I have left when I do that? 2/8. Is that my simplest form of my mixed number? No. Someone tell me what I can simplify this by.
2.
Yes, both of them are even numbers. You can divide both numerator and denominator by 2. So my whole number stays the same. It does not get simplified. It's a whole number. But what's 2 divided by 2?
1.
What's 8 divided by 2?
4.
So changing 10/8 into a mixed number would result in the mixed number 1 1/4. Yes.
So can we use these on quizzes and tests if we need help? Or do you want us to just draw them on the paper?
Use what? These?
Yeah.
If you need them. And you're not always going to have a problem that's represented in these fraction bars. But for now, if you need them, absolutely. Let's try one more thing and talk about one more thing about mixed numbers. Hold on just 1 second. Every single fraction bar in the history of fractions is really a division sign.
Yeah.
So the easiest way for me as a person to turn a improper fraction into a mixed number is to just do the division. So I need to find out, well, what is 10 divided into groups of 8? Well, how many times can 8 go into 10?
1.
1 times 8 is?
8.
10 minus 8 is? 2. Here's the quotient that you get is your whole number. The remainder becomes your numerator.
And then just 8 is your denominator.
And the divisor is your denominator. There I am again at 1 2/8. Again, we can simplify that because they're both even into 1 1/4. This method of just doing long division is much easier for me. If you like to use your reasoning and think, well, I know every 8 pieces is a whole, you could do that as well. Essentially, you're doing division anyways, right? Yes. Simplify.
You can also divide 2 by 8 and you get 4.
You cannot divide 2 by 8. You can divide 8 by 2. Right? Is that what you meant to say? And then you get 4. And then what?
And then you put a 1.
Because 2 divided by 2 is 1. That's what you just did. All right. Last topic that I need to make sure that you guys know how to do is, what do you do if you are given 2 fractions with different denominators? So we're going to talk now about actually finding common denominators. So I'm going to use the example 1/2 plus, 1/2 plus 1/3. Okay? So I have the fractions 1/2, and I want to add that to 1/3. If I took these fraction bars and added them, did I just add 2 fractions?
Yeah.
I sure did. Tell me the answer.
2/5.
You can't tell me because my pieces are not in the same size. So because my pieces aren't the same size, you can look at this and say, well, it's however big that is. But you can't actually give me a number, a value for the answer. So instead, we want to make sure that our pieces are the same size. So we want common denominators. In order to find common denominators, we have to look for the greatest, the least common multiple. Let's talk about multiples. In the problem, 3 times 4 equals 12. 3 and 4 are considered factors of 12. 12 is considered a multiple of 3 and 4. So what I want to do is I want to take both my denominators and I want to list out their fact families and I want to find a multiple they have in common. Let's start with 2. 2 times 1 is?
2.
Times 2?
4.
Times 3?
6.
Times 4?
8.
Times 5?
10.
Times 6?
12.
Okay, I'm going to stop there. Now I'm going to do 3. 3 times 1 is?
3.
3 times 2 is? 3 times 3 is? 3 times 4 is?
12.
Do you see any common multiples that I have between 2 and 3? I see 12. Someone said 12. What else do I see? 6. Every number in the history of the world has an unlimited amount of common multiples because these numbers can keep going and going and going. But we want to look for the least common multiple. Now, if I chose the common multiple of 12, I'm still going to get the right answer. As long as I correctly make equivalent fractions, but I would have to simplify at the end. Very good.
12 divided by 2.
Very good. So just being able to identify the least common multiple is just one step of adding and subtracting fractions with unlike denominators. The next step is to actually take your fractions that you're adding up, making equivalent fractions with those denominators. So we're going to stop for today, and we are going to practice these skills as well as a little bit of adding and subtracting with like denominators, and then you guys are going to move ahead into a Nearpod. Okay? So